So for this first talk, we have Chen, the Daniel Kahneman Professor at the University of Michigan School of Information, who's a leader in behavioral market design research and implement them in real world labor markets. And for the discussion, we have Chris DeLuzio, Policy Director at Pitt Cyber at the University of Pittsburgh, and Jana Galus, the Assistant Professor of Strategy at UCLA Anderson. And if you're just joining us, there will be a discussion at 5 to 5:30 where we'll be in breakout rooms, like talking about these topics. So Yan, thank you so much. The floor is all yours.
Thank you, Sarah. So let me share my screen. Can everyone see my screen? Yeah.
Yes.
Okay. So thanks for organizing the conference and for the very exciting format. So I'm going to present a field experiment on motivating experts to contribute to digital public goods. This is a field experiment conducted on Wikipedia, and it's with Roster Farzan from Pitt, Bob Kraut from Carnegie Mellon, and two of our students at the School of Information, Iman Yakazari and Ark Fanjo Zhang. So Ark is now at Google, so he's graduated. So digital public goods by now is familiar. It's sometimes they're called user-generated content, depending on which field you're coming from. Open source software is a big class of such digital public goods, online reviews, internet encyclopedia. So Wikipedia is, I think, the poster child. It's 20 years old this year. And online Q&A sites such as Stack Exchange. So let me talk a little bit about digital public goods and what's special about it. So they are non-rivalrous and non-excludable by choice, because exclusion is fairly easy. You can just set up authentication. So for instance, the founders of Wikipedia decided it was a conscious decision not to exclude. The other part is expertise matter, that inputs are not perfect substitutes. So if you are an expert in a domain, the quality of your contribution will be higher. Marginal cost is low because you already know the domain. And that identity and affect might play a role. So you've worked on coordination game for 20 years, maybe you care about conveying the right ideas to the public. So in this paper, we're going to ask several questions. One is, what motivates experts to contribute to digital public goods? Specifically, we're looking at social impact. So this is a setting where we're influenced by a natural experiment occurred on the Chinese Wikipedia. So Zhang and Zhu had a really clever paper that was published in the AER that looks at government blocking of the Chinese Wikipedia as an exogenous shock to the readership. And so they find that when the government blocks Wikipedia, the readership dropped significantly, but the editors who are located outside of China, so for instance, in Taiwan and Singapore, where people use traditional characters, so you can identify who are in mainland China versus overseas, they were not blocked, but their effort, their edits were reduced by 40% during the block. So which means in that case, people care about the social impact. We also ask about private benefits, so for the contributor themselves. And the last piece that we look at, which we think is relatively novel within economic models of public goods provision, is the matching of expertise with tasks. So our field is Wikipedia, so I don't need to introduce Wikipedia. So the people who contribute contribute to Wikipedia, we, the community used the word Wikipedians. So I didn't come up with it. So most of the active contributors are non-experts, and experts seldom make contributions. So think about the last time you read a Wikipedia article and find an error, did you click the edit button? I cannot conduct a survey now, but most of the times when I present to a live audience, maybe 1 out of 50 has made a contribution. There are two exceptions. One is mathematicians. The other one is medical doctors. So I talked to people in the foundation, the Wikimedia Foundation that runs Wikipedia. No one actually understood why mathematicians contribute so much. But for the medical doctors, they're actually NIH-funded efforts. So medical doctors realized that they couldn't prevent their patients from reading Wikipedia articles, so they should make them better. So NIH funded some initiatives to essentially mobilize the experts. So there are two holes in Wikipedia. One is science articles. Because of the lack of expert contributions, they tend to be imprecise, erroneous, and incomplete. So these are holes that the foundation acknowledged themselves. The other one is the lack of representation by women. So we're not going to touch this. Because of this, it also leads to biased coverage. So we want to look at, how do we motivate domain experts to contribute? So this is an example of something that we're familiar with. The article on instrumental variables says that the method of instrumental variables is used to estimate causal relationships when controlled experiments are not feasible. And we know, so this was accurate in the 1980s, but now we often use randomization as an instrument, and it's also regularly used in lab experiments. So for someone who studies this area, who's a domain expert, it's fairly easy to bring the article up to date. So I'm going to do a very quick literature review. There's the classic theoretical public goods literature on voluntary contributions and the mechanism design approach and so on. So, and also a very large literature on lab and field experiments on public goods. So I'm just going to be lazy and refer people to two landmark surveys. One is John Ledger's survey in the first handbook. The other one is Lisa Westerlund's survey in the second handbook on charitable giving. So, so what we're asking here is what motivates Wikipedians who are insiders. The literature has identified several things that motivates the insiders. So reciprocity and social image, and Jana, who's the discussant of the paper, has a very a big paper on the effect of symbolic awards on new Wikipedia editors. So this question has generated a fair amount of research across different disciplines. The last one, which is Costley et al., also is interesting in the sense that he used a machine learning model that matches a Wikipedian's past edit with articles that needs edit. So what we're doing in this paper is what motivates domain experts, and an overwhelming majority of them are outsiders who never edited Wikipedia. So we have a simple theoretical framework, and the setup is very much constrained by what we can actually measure. So, so we have a set of agents who selects a contribution level, And the new feature is what we call matching accuracy. And it's a parameter m between 0 and 1. And we can operationalize it with cosine similarity later on. And then there's an output. If you put in time and resources to edit the article, your output is determined by your input and the match. And so the total public good produced is just going to be the sum of everybody's contributions. And this is, think about this as one Wikipedia article. So the social impact in this context is just the number of views. And this is something that we will experimentally manipulate, exogenously manipulate. And so the social impact can be thought of as VI of n, the number of views. Think about the government blocking of the Chinese Wikipedia, times f of y, okay. And there's also a private benefit component, which is the benefit from the active contribution. So we use W, which is borrowed from Jim Angiolini's warm glow model, but it's more general than warm glow. So your private benefit is a function of n, which is the number of viewers, times your contribution. And the cost, one can think of that as having two components. So when you contribute to Wikipedia, there's a cost of contribution, it takes time and resources. And there's also an opportunity cost, namely, the time you're not spending on editing Wikipedia articles, you can, work on your own research, for instance. So I use R here. One can think of R as the reputation of an expert. And again, we're going to be able to measure the reputation in the field. So we use a two-stage design. So in the first stage, we elicit interest. And so once I present the experiment design, it will become clearer. So here the expert forms beliefs about M, the match quality. Then they decide whether to participate. And in the second stage, once you decide to participate, they receive recommended tasks, so MI is realized, and then they decide how much to contribute. Here are some experimental reasons for using a two-stage design. We do it primarily to increase power. So this is a standard backward induction exercise. So we'll look at the contribution stage first. So it's an optimization problem. And so once you know the match quality, here are some comparative statics. If more people can consume the public good, that increases equilibrium contributions. If the private benefit is more salient, it increases contributions. Match quality and increases contributions, and opportunity of cost of time, which is your reputation, has the opposite effect. And then we go back to the first stage to look at interest elicitation. So ceteris paribus, an expert is more likely to participate if more people consume the public good, if the private benefit is more salient, and if the opportunity cost is lower. Okay. And so now I'm going to move to the experiment design. So we're going to use a 2x3 factorial design. The first factor is social impact. And so before we run the experiment, we processed a Wikipedia data dump. And so one little interesting fact is Wikipedia has a monthly public data dump. And so anybody can just go and do whatever analysis you like with it. It has every editor's entire history of edits. So, so we computed the average view of a Wikipedia article is 426. So it's just at the time that we process the data. So we essentially tell everyone what the average number of view is. And in the high view condition, we say that we will only recommend articles which has more than 1,000 views, which is twice as much. On the private benefit factor, we either don't mention citation at all, or we say we will recommend Wikipedia articles that might cite your work, may include some of your publications in their references, and might refer to some of your research. So these are three different ways of saying the same thing, and it's mainly to avoid getting an effect simply because of the specific words and phrases you use. So there's some psychology research that recommend this practice. And then we checked afterwards, there's no difference in any of the three versions. So we randomly use one of the three for each participant. And there's also another push, which is citation and acknowledgement. So there's, in addition to the citation, we say that we will publicize your contributions on the Wikipedia, on the Wiki Project Economics page, which is essentially a group structure within Wikipedia. So I'll talk a little more about that. So went through, power calculation. So here is our intent to treat. So each experimental condition has about between 600 and 700 participants. And where do we get our participants? We started with a field that we know something about, which are, economics. So we contacted academic economists, and so we retrieved the information from REPEC. Why REPEC? Because it doesn't prohibit people from using the email addresses. The second reason is that it has an open paper archive, where we can use to match expertise with Wikipedia articles. There's also a reputation score, in the sense that we actually use two different reputation measures. REPEC has a ranking. So if you're on REPEC, they'll send you an email every month telling you your percentile ranking. From the outside, we only know whether you're above or below the top 10%. So the expert selection is that we look at people who have posted at least 5 articles in English. This is primarily for the accuracy of our matching algorithm. So if we recommend 1 or 2, they might not match as well, but with 5, we're fairly reasonably confident that at least one of them will match. So how does that truncate the distribution of economists? So here's the distribution of the number of publications on REPEC. So we made a cut here. And that essentially cut off, probably more junior economists, people who posted 1 or 2 or 3 papers on REPEC.
And I'm just giving you a 5-minute warning.
Oh, 5 minutes left. Oh, okay. So I'll skip the algorithm. So how do we, so here's the email where we say that we personalize and we have the average number of views. So this is someone who's in the high view condition. And we say, we may include some of your publications in the reference, the Wikipedia article. So this is the private benefit, high view, and Bobana assigned the email. And here's the public acknowledgement, which is Wikipedia, Wiki Project Economics. This is what the second email looks like. All right, so forget about the interface. I'm going to go to the result. So we contacted 4,000 experts. 84% of them opened the first email, and 1,600 said yes. They were sent the second email, 500 commented on at least 1 article, and the average is 2. Okay, so here's the first stage result, which is the baseline is high. So no citation average view will give you 45% interested. And if you're in the citation and high view condition, there is a 6% percentage point increase. So this is the regression table that looks at the effect size, which is compared to the baseline, citation and high view together will give you a 6 percentage point increase. So reputation, so this is the covariate. Once you add the covariate, a 1 standard deviation increase in log abstract views is associated with a 25 percentage point increase in the likelihood of a negative response. So this is consistent with our comparative statics. Moving to stage 2, we use measures of contribution length and quality, but match between your RePEc article abstract and the Wikipedia article is captured by cosine similarity, which is roughly speaking the overlap of words. And so this is one article where how the expert contributed compared to the original one. So in this case, the expert contributions makes it much more nuanced and give an overview of the experimental results on the traveler's dilemma. So it's a more comprehensive and updated view of the experimental results. And so for the second stage, I am not going to show, I'm just going to, so what we did, because of selection in the second stage, we primarily look at prediction. So we use the random forest model to look at the factors that predicted the length and the quality of contributions. And the results are fairly consistent in the sense that year of PhD, that's your seniority in the profession, match quality, which is measured by cosine similarity, and Wikipedia article length are the top 3 most important predictors of both the length and also the quality of experts' contributions. So let me conclude in the last 1 minute, I guess, that to elicit interest, citation together with high view has a large effect over the baseline. For high quality contributions, citation and public acknowledgement at high view is associated with high quality contribution. So for predictors of contribution length and quality, match accuracy, which is how good the task is matched to the volunteer's expertise, is the most significant predictor of both quality and quantity. So the idea of increasing contribution, what increases contributions to digital public goods, citation in combination with social impact, public acknowledgement, and match of expertise. And so with computing, we could use recommender systems, we could use natural language processing techniques to help with the match. So that's the end of my talk. Thank you.
Thank you so much. Let's just give Jana a round of applause. Thank you so much. Okay, so I'm going to pass this to Jana and Chris for discussion.
So we did not have any questions in the chat. If anybody wants to ask questions, please. Oh, I think there's Sarah. Did you deliberately raise your hand? No. If there's any questions, we're happy to raise those first. There were none so far. If not, and you're thinking about possible questions, so this is I think this is extremely exciting to find that match accuracy plays such an important role also, and to be able to benchmark this in such an innovative field experiment. Do you have a sense about the mechanisms possibly behind that result? Could you give us some more information about, because of course the talk had to be so quick, maybe about how the match accuracy was again displayed to participants when seeking to motivate them? And could it have prompted like an expectation that I have to invest less effort? So in terms of the opportunity costs, or perhaps that this is, where I have a unique expertise, and if I don't do it, the social impact motivation basically as driving that result?
Yeah, so there's sort of two signals. One is in the first email that we send, we have your field in the topic, and also in the, can we send you some articles in behavioral and experimental economics or mechanism design? So that if that's a good match, that's a first good signal. Once you say yes, what we did is we took your 5 most recent papers on RePEG. We took the abstract and did a match with the Wikipedia articles, the set of Wikipedia articles, and then we recommended the 5 articles. And so if you look at the articles that's recommended to you, you should have a pretty good sense of whether that's something that really is in your field of expertise. And we actually have feedbacks from experts who said, these 3 are good, the other 2 are not so good. So I think it's both cost, the cost of actually making contributions, and also perhaps identity, which is you care about this information conveyed correctly.
If I might, jump in, what I found most interesting and exciting about your work and some of your findings is there's, to me, a very obvious practical application. My work often involves convening experts for task forces and commissions to tackle a problem or study an issue. And so I'm wondering if you could maybe talk a bit about your findings about the factors that would predict the length and quality of contributions, how we can learn from that and apply in settings like conferences, joint task forces, things like that, how we can get the most maybe impactful expert participation.
Yeah, thanks, Chris. So the predictor, one is constant similarity, which is the match quality. The other one is actually seniority, basically your years since PhD. And the third one is the Wikipedia article length, which is if there's very little, if it's a stub or a poor quality. So Wikipedia itself grades articles in 6 categories, and you can find that on the talk page. There's not much to comment on. It's also too effortful. So if it's a featured article, which is the highest quality, it's also hard to improve. So the mid quality zone is actually the BC class articles are I think the sweet spot for making recommendations and for people accepting the recommendations. I think in general, in terms of volunteering, it's lots of the volunteering tasks actually involve expertise. For instance, mentoring inner city youths. So this is an example that Raj Chetty raised. That's something that he was involved in doing. So if a kid is really interested in robotics, you want to match her with a robotics expert. So these type of matches, I think match quality plays an important role on the outcome.
Thank you.
Xiaohong, you have a question? I hope that I pronounced your name correctly.
I think Scott has a question too. So there was a queue.
So I have, okay. I have a question. I think that's a very high response. Maybe that's because the email is from you and Robert. I mean, 2 leading economists to other economists. Do you think this result can generalize to, like, if the email is from a worker in Wikipedia? Because that's a general side. That's a general situation.
So basically it's an expensive experiment, so we did not vary we did not vary who sent out the email. So in principle, one can also make it a factor, an exogenous factor on who sent out the email. We just didn't have the power to do that. But I wanted to say that there's some indication that it's not just the sender, but the match is really important. The reason is Bob and Roster, two of our co-authors, conducted an experiment asking psychologists to contribute to Wikipedia. Before our experiment, they sent the email out from the American Psychological Association to 9,800 psychologists, and the response rate was 2%. So it was sent out, from the secretary, who's also a prominent psychologist, in his name. But what they did was they used the categorization in the APA directory. Would you make contributions to articles in social psychology? It's too broad. So I think our match, there's a lot of behind the scenes work in making the match accurate. And so I think even though their experiment was not designed to test the same set of things, and we can't really compare, but just the sheer difference in the response rate make me think that, maybe the coarse versus fine match makes a difference.
Thank you.
I think Scott, did you?
Yeah, Scott.
Yeah.
Mm-hmm.
I just want to actually build on that question. I mean, that we know from other experimental work that economists tend to be different than non-economists, right? That we contribute less to public goods and that sort of stuff, and we respond to incentives and that sort of thing. If you were going to pick a second discipline to redo this experiment in, you just mentioned psychology, and you thought by studying that second discipline, you'd learn the most. Which one would that be and why?
So we were thinking about that, and we were actually thinking from not that economists are fundamentally different from other people, but because
people or other people. I'm sorry.
Okay, we were actually thinking about the availability of open archives. So we were able to do this, the match, because of REPEC, and another discipline could just be physics or computer science. And so both the disciplines use the archive extensively. And so, basically we could just grab the articles in the archive and do a similar match between the archive article and the Wikipedia articles.
But would you expect what differences would you expect between computer scientists or physicists and economists? Do you think the results would be the same, or would you think that you'd find cultural differences by discipline?
We were very surprised by the initial response rate, which is 45%, without even mentioning, citation benefit or the view, just the average view. But we lost 2/3 on the way from, yes, I'm interested, to actual contributing. And so I'm wondering whether the other two disciplines, maybe the attrition will be lower. It's all speculation. Partly because I think there is a perfectionist trait in most economists from our publication process. And whereas at least in computer science, which I also publish some articles in, it's faster. There's in a month you get 6 referee reports, and you don't have to follow all of them. You have a week to do your R&R. So I think people are more likely to say, this is something I'm going to do it by this date, and it doesn't have to be perfect. And I think that's more congruent with the Wikipedia culture, in the sense that you add something, if it is not perfect, other people will improve upon it. Whereas the economists in us would all want to do it perfectly. Josh Enquist decided to assign the articles that we recommended to him to his graduate student. The graduate student completely rewrote the Wikipedia article on regression discontinuity design. And of course, it was actually taken down because there were a group of people who were working on the initial article and improving it. You cannot just say, this is bad, and here's a better one. I think incremental improvement is much easier. It's better to, easier to get accepted in the Wikipedia community.